So for the internal energy equation, we can find out using this Maxwell square. Okay, so first we have to find out the position of U. So in this square, first you have to draw this square like this. So you can remember like Satya is for Satya, P for Prakash. Satya, Prakash, very tired. And this one is Hey God, ab utha le. So like this way you can make this square and then put these two arrows. Alright, fine. So in this using this Maxwell square, we can find out some of the relationships, some important relationships between these thermodynamic quantities. And okay, so let's get started. So du. So if we have to find out the equation for du, see. So first we have to find out the positions. So this u is present in between this s and p. Alright, so that's why I have to write the differential form of the ds and the dv as it comes between s and v. Alright, then just check what is there opposite to these two quantities. Okay, like here I have to check what is there opposite to this s. So opposite to this s, t is there. Alright, this t is there, so I can write tds, and opposite to this v, P is there. I have to write here the PdV, and the sign that depends on the arrow. If you have, so in this arrow, if that quantity is present near this arrowhead, then we have to put the positive sign, and if it is present near to this tail part, then we have to put the negative sign. Sorry, sorry. Just reverse it. So if it is present the arrowhead part, we have to put the negative sign, and if the quantity is present near to this tail part, then we have to put this positive sign. Alright, see, so here and here in this case the quantity, sorry, the signs depends on this s and v. Alright, so s is present near to this tail portion. Alright, so that's why I have to put here the positive sign, and here the p. Alright, not the p, the v. So in this case the v is present near this arrowhead, so that's why I have to put the negative sign. So here I got the relation for du, that is tds minus pdv. So likewise we can find out the relations for dh, dg and da also. So now we'll try for this dg, that is the Gibbs free energy, the equation for the Gibbs free energy. So first I have to find out the position of d. So this d is, so this g, it is present between this p and t. So I have to write the differentiate form of dp and dt, and opposite to this p, v is present, so I have to write here v, and here opposite to this t, s is there, so that's why I have to write here s. Again, this, as I told you earlier, the signs depends upon this two quantity, that is pressure and temperature. So that's why here the P, it is present near the tail portion of this arrow. Alright, so that's why I have to put here the positive sign. Alright, and for this temperature we have to put the negative sign. So next we can find out, similarly we can find out the relationship for the equation for dH, that is the enthalpy. Okay, so this H, it is present between this S and P, that is the entropy and pressure. So we have to write the differentiate form of entropy and the differentiate form of pressure. Again, opposite to this S, T is there, so that's why I have to write here T, and opposite to this P, V is there, so that's why I have to write here V. Again, this S and P, okay, both are present nearest to this tail part. Alright, so that's why I have to put the positive sign. Done. Then the next one is dA, that is the Helmholtz free energy. So it is present between this V and T. Alright, so that's why I have to write the differentiate form of V and the differentiate form of T. Also, opposite to this V, pressure is present, right? So that's why I have to write here P, and opposite to this T, like this T, entropy is there, so that's why I have to write here S. and the signs depends on this S and T. Okay, so in both the cases arrowhead is there, that's why we have to put the negative signs. Alright, so these are the relationships or the equations that we can find out using the thermodynamic Maxwell square, in thermodynamics using Maxwell square. I hope you understand this. And yes, one more thing, all the state functions are exact differentials, so we can find out some more relations using these relations. And how? See, so in this case, using this relationship we can find out some more relationships. How? As you know that dz is equals to mdx plus n dy. Understand? Like z is the function of x and y. If z is the function of x and y, so we can write the dz function as mdx plus ny. You know this, the exact differential. So you don't need to remember this formula. Just find so using this formula we can find out the other relationships. Like see, in this case, the first case, using this, so del m by, here in this case, del m by del y at constant x is equals to del n by del x at constant y. So this is the condition for exact differential. Yes or no? So using this formula we can find out the relationship that is here. Consider these equations. Okay, so here this is the m, this is dx, alright, and here it is n, and this is dy, and this one is dz. See, so I can write here del t by del v at constant s would be equals to del p by del s at constant v. Alright, so I can put the negative sign here, or here also you can put the negative sign, no issue. Okay, so these are the exact differential. So these are the so that's why I have already told you that all the state functions are exact differentials of each other. So in order to be exact differentials, so they must follow this. Okay, fine. So using this we can find out all other relationships. Those are, I can write it here. See, the next we can find out minus del s by del p at constant t would be equals to del v by del t at constant p, then minus del p by del s. I have already written this. Alright, okay, we will use this equation. Fine, this equation, so I have written this formula. Alright, now I'll use this equations. Okay, so I can write del t by del p at constant s would be equals to del v by del s at constant p. Both are positive, so we have to put the positive sign, and it's already in positive sign is there. Okay, and using this formula we can find out the relation del v by del t at constant p would be equals to del s by del p at constant t. So here it is negative. Fine. So all these formulas or the equations can be derived using these four equations. So we just have to remember these four relations, and you know how to find out these four equations using this Maxwell square. Okay, so using these four equations you can find out these 1, 2, 3, 4 relations. Alright, one more thing is there, you can find out one more thing also. Suppose here you have to find out the value of this the pressure. So what I have to do is, see, in this case if I have to find out the pressure, so I can write P is equals to del U by del V at constant del u by del v at constant s. Alright, so using this equation we can find out the value of p also. Correct, del u by del v at constant s, and here the negative sign is there, so that's why I just put this negative sign. Okay, so likewise we can find out the s also. How? So that's how we have to write out del g. So I'm using this equation, del g by del t, del g by del t at constant p, negative sign. Then for v we can write del h by del p at constant s. Correct. So again for this, so that's how you can find out this ps. Okay, so for that, in order to write these equations, you must know these four equations.